Easy BTech. Today we will learn about the flux linkage of a one subconductor of composite conductor. Flux linkage of a one subconductor in a composite conductor. Composite conductor. Composite is also called as stranded conductor also. Stranded conductor. Okay. First of all, we have to know the stranded conductor. Okay. Take the stranded conductors are, suppose number of strands is there, like that number of strands, all the strands. I am not drawing all the strands, but we have to assume it is a stranded conductor. The conductor numbers of this stranded conductor is first stranded conductor, second stranded conductor, third stranded, fourth stranded, up to assume that small n number of subconductors is there in the conductor. Therefore, assume a point P. Assume a point P is far away from the conductor. Assume a point P is far away from the conductor. This is point P. Point P far away from the conductor. Now, the distance from first subconductor to point P is d1P. Next, the distance from second subconductor to point P is d2P. The distance is d2P. Now, the distance from third subconductor to point P is d3P. Okay. Like that, the distance from N to P, the distance from N to point P is this is dNP. Okay. From 4 also it is a d4P. Okay, if you draw from subconductor 4 to P, it is d4P. I am not taking all the conductors, I am taking only 2 to 3 conductors to P. Now, here the current flowing through each conductor, it is I1, it is I2, I3, I4, like that. The current flowing through the nth conductor is I1. Here assume this current, sum of all currents is equals to 0. Therefore, I1 plus, I2 plus, I3 plus, up to IN plus IN is equals to 0. This is equation 1. Next, first of all, we have to derive the flux linkage subconductor 1. Flux linkage of subconductor 1 due to the current flowing through its own current, that is I1. Okay, current flowing through what is the current flowing through the first subconductor? It is the current flowing through the first subconductor is I1. Okay, now you can go to the expression, how to write the expression. We represent the flux linkage is psi. We have to calculate the flux linkage between 1 and P due to the current 1. What is the expression? Already you derived this one. 2 into 10 power minus 7 ln. The numerator is, how to write the numerator for this case? The numerator is, here the numerator is the distance from first subconductor to P. This is d1P is the numerator. Therefore, the numerator is, I will write in another color, it is d1P divided by the distance of 1 to 1 conductor, it is d11. This is numerator and denominator. How to write with the expression? Okay, first we have to write which current it is. It is first current, first subconductor current. Therefore, we have to write the distance between 1 to p is the numerator. 1 to p is the numerator, and the distance from 1 to 1, it is denominator. Keep in mind this shortcut, it is very useful in examinations. Psi 1p1 is the flux linkage between conductor 1 and p, the flux linkage between 1 and p due to current flowing through the first subconductor. That is, the shortcut equation is 2 into 10 power minus 7 ln the distance from 1 to p divided by 1 to 1. We have to use the same expression for remaining also. Now here one thing we have to observe, the conductors 1, 2, 3 up to n. The flux linkage, this is the expression for flux linkage of conductor 1 due to current flowing through the subconductor 1. Now, the flux linkage of conductor 1, the flux linkage of conductor 1 due to current flowing through the second subconductor I2. Some amount of flux is induced in the first subconductor or not due to current flowing through the second subconductor. Like that, from the third current is also some flux linkage is there. Like that, nth current is also some flux linkage is there. Therefore, we have to write that flux linkage. Now, write the flux linkage expression. For this case, it is psi 1p, the flux linkage between 1 and p due to current flowing through the second subconductor, it is psi 1p2. The expression is 2 into 10 power minus 7 ln. What is the numerator here? The numerator is the distance from 2 to p, d2p divided by the denominator is d21, d21. Okay, d12 or d21, both are same. Like that, we have to write the expression for psi 1p3. Try to write the expression for 1p3. It is 2 into 10 power minus 7 ln the distance from 3 to p. The distance from 3 to p is d3p divided by the distance from 1 to 3 to 1. This is d31. Okay, like that we have to write the expressions for all the conductors. Expressions for all the conductors. Finally, what you get? Due to the current flowing through the nth subconductor, it is 2 into 10 power minus 7 ln dnp divided by dn1. Okay, this is the total flux linkage of conductors due to subconductors, current flowing through the subconductors. Now, what is the total flux linkage of conductor 1 and p? It is sum of psi 1p1 plus sum of psi 1p2 plus psi 1p3 up to psi 1pn. Add these expressions. Okay, we go for another page. Add these all expressions. What you get? Psi 1p equals to, if you common 2 into 10 power minus 7, the expressions become I1 ln d1p by d11. We can write it as r dash also. I2 equals I2 ln d2p divided by d21, like that up to dnp divided by dn1. This is the expression. Now we have to write this expression. Now we have to write this expression is ln of a by b. You can write it as ln of a plus ln of 1 by b. Okay, divide this one. divide this above expression by using this formula, it is 2 into 10 power minus 7 in bracket I1. Assume that it is A, it is 1 by B. First we have to write the 1 by B terms, second terms. First we have to write the second terms. The second term is I1 ln 1 by D11 plus, next we can write the first term. Otherwise we can write the same expression. Okay, no problem with that. You no need to write the first one. Okay, here one is A is D1P plus B is I1 ln 1 by D11 plus, same we have to use the same expression for second one also. It is I2 ln D2P plus I2 ln 1 by D21. Like that we have to apply the expression for same last one also. Sorry, here it is IN ln. Therefore it becomes IN ln DNP plus IN ln 1 by DN1. This is the expression. Now write all the denominator terms at one place. 2 into 10 power minus 7 I1 ln 1 by D11 plus I2 ln 1 by D21 plus up to IN ln 1 by DN1 plus the denominator terms I1 ln 1 by, numerator terms. The numerator terms are D1P plus I2 ln D2P up to IN ln DNP. Okay, this is the expression. Okay. Now from equation 1, what is equation 1? The equation 1 is sum of all currents in the conductor is 0. I1 plus, initially we assumed that I1 plus I2 plus up to IN equals to 0. From this expression, what is IN? IN equals to I1 plus I2 plus up to IN minus 1 is minus of this. Okay. From this, IN equals to minus of I1 plus I2 plus up to IN minus 1. Substitute this equation in here. What you get? What you get if you substitute that equation? It is 2 into 10 power minus 7 I1 ln 1 by D11 plus I2 ln 1 by D21 plus up to IN ln 1 by DN1. I have to separate this plus, no need to separate this. Okay, plus you can write I1 ln D1P plus I2 ln D2P plus up to plus minus of I1, minus of I1 plus I2 plus up to IN minus 1 ln DNP. Okay, I have to write this expression. Substitute IN here. Okay, you can get that expression. From that expression, what you get is 2 into 10 power minus 7 I1 ln 1 by d11 plus I2 ln d21 plus I3 so up to we can go to up to in ln 1 by dn1 plus I1 ln d1p plus I2 ln d2p plus up to we can get it is minus I1 into ln dnp. Multiply these terms, minus of I1 into ln dnp, we get minus I1 ln dnp minus I2 ln dnp minus up to minus in minus 1 ln dnp. Okay, here one term is also there. Before going to this, it is plus in minus 1 into dn minus 1 into p, n minus 1 into p. Okay, now what do you get from this? Therefore, the final expression is 2 into 10 power minus 7 I1 ln 1 by d11 plus I2 ln 1 by d21 plus up to in ln 1 by dn1 plus write I1 terms at one place. We have to, where we are having the I1 terms, we have to combine this I1 terms. I1 ln d1p minus I1 ln dnp. Okay, the formula here we have to use, that is ln of x minus ln of y, we can write it as ln of x by y. Okay, therefore what you get here? What you get here? It is, write that term in this equation. What you get? I1 into ln d1p by dnp. This is x, this is y. Okay, x by y we can get d1p by dnp. Like, I have to write I2 equals to I2 ln d2p divided by dnp. In this expression it is, this is x, this is y. Okay, next plus up to plus I n minus 1 ln d n minus 1 to p divided by dnp. This expression dn minus 1 p divided by dnp. Okay, now therefore the distances, if you go for the diagram, here the distances, assume that it is far away from the conductors, assume that the far away from the conductors 1p and np, 1p and np, all the distances are approximately equal to same. d1p approximately equals to d2p approximately equals to, like that, approximately equals to dnp. All the distances are same because we are assuming point P is far away from the conductors. We don't know where it is. It is very far away from the conductors. The distance between the conductors is less. That's why assume that all the distances are same. Therefore, now the expression becomes, all the distances are same. Therefore, it becomes, the distances are same, it becomes 1. This part becomes dnp by d1p, d1p by dnp, d2 by dnp, and last term becomes 1. From this expression, ln of 1 becomes 0. Ln of 1 becomes 0. Therefore, the entire part ln of 0, this one becomes 0, this one becomes 0, and this one becomes 0. The remaining expression is only this one. The remaining expression is only this. We have to rewrite this expression. Therefore, the flux linkage of conductor 1 is equals to 2 into 10 power minus 7 in bracket I1 ln 1 by d11 plus I2 ln 1 by d21 plus up to In ln 1 by dn1. Okay, we can write this d11 is also the self distance of the conductor, it is r dash. The self distance is r dash. Okay, compact form of this expression, we can write 1 1 2 1 1 2 all are same. Therefore, the flux linkage of conductor 1 is in complex form, compact form. It is 2 into 10 power minus 7 sigma x equals to 1 to n. It is Ix ln 1 by d x1 or 1x, whatever it may be. This is the final expression for flux linkage of a one subconductor in a standard conductor. Keep in mind. Okay, this is about the flux linkage of a one subconductor in a composite conductor. Okay, thank you.